Students, welcome back to Stanford Code in Place. This is week 6. Believe it or not, this is the last week of our class. Can you believe how time has flown? So we've got a lot to cover today, so let's jump into it. Well, as always, I've got a cheat sheet for you this week, and there is a lot in this cheat sheet. So not only am I going to list what's necessary this week, but since this is our final week, I'm going to give you some extra resources. So first up, we've got this heads up program. That is the thing that we're actually going to be working on in section. As always, I've got a new graphics project. So lists and dictionaries are what you guys are learning this week. And I also wanted to point out this erase canvas worked example because that I think will give you a hint as to what's going on for baby snake, which is a bit confusing because we're not covering baby snake in section, at least we're not supposed to, but it's really the big assignment for the week. So I'm gonna show you my baby snake and talk a little bit about how to do that. Going forward, here's two references that you should plan on using. One is the W3 Schools Reader, which is their training. Whenever I want to look up something in Python, I generally go to them because they have very concise code with examples, and it just seems to be the best one that I found out there. And then where to go after Stanford Code in Place? Well, one recommendation that I will make to you is to try out the Automate the Boring Stuff with Python book. It's a book. It's free online, but not only is it a book, the author actually has published YouTube videos for the entire book. And it's Python with an emphasis on how to make stuff on the web interactive so that you can actually do things with the web, and I think it's a great way to continue on your learning. So lists and dictionaries, they gave you a very cursory overview of lists and dictionaries, and the TAs threw a lot of stuff at you, so many things on there that they had not introduced before and were not in the documentation that I lost count. So I want you to relax when you're watching those videos and just try to absorb the high-level things. Don't worry too much about the exact code because you may not be using some of these features, but you very well may. The problem that they've given us this week is a very, very simple example using lists only and not dictionaries. So first thing I want to do is walk through lists and dictionaries again with you very practically. So we're just going to go through a piece of code, and I'm going to use this program that I've shown you before called Python Tutor. And here is a graphical example, of how these lists and dictionaries show up in memory when you create them. And I want you to look at these two things for a second. Just look at them. Note, what are the differences between these two things? I mean, other than the fact that one's a grocery list and one's a list of colors. Certainly one thing you probably noticed is, well, this one's horizontal and this one's vertical. That's not such a thing to worry about in memory because this is just a representation. But this is one-dimensional. Okay, so it's just a list of items. Just one-dimensional. Whereas this is kind of two-dimensional, right? There's actually pairs here. We call these things on the left the keys, and these things on the right the values. Now, if you read the list carefully, you might notice something about them. One thing is that here we have, oh shoot, I didn't get the right image here. I'll show you when we jump into the program. But one thing about lists that's very important is that you can have two of the same color in a list. You can have red in one place and red in another. Whereas in the dictionary, you cannot. You can only have one item in a dictionary in the key. And there's so that's a big distinction. Thinking about when you would use these things, well, you can use lists for a ton of different things. It's just anytime you have a collection of items. But when you have something you want to look up, okay, typically one item to one item, you can use a dictionary. Even if it's one item to many items, you can still use a dictionary because dictionary doesn't limit you to having just numbers or strings. You can put a whole data type in here. You could put a list as the value in a dictionary. So the main thing to remember about dictionaries is that you've got a key value pair. Okay, whether you can think of that like a name and your telephone number, or your name and a student ID, or your name and a credit card number. Those things are unique. So let's get into some code here. So I wrote some code down here, but rather than just kind of look at it, let's jump into Python Tutor. Let's see what it actually does. All right, so I'm gonna again, Python Tutor it teaches you in all these different languages what actually goes on in memory using visualize execution. This is really cool. So first thing it's going to do is going to create this list with red, orange, yellow, blue, violet. Let me actually show the list. Yeah, that's the full list. Okay, so let's go ahead and step through that. So immediately we get 5 things. Now notice the indices, 0, 1, 2, 3, 4, 5 items. We start with red. If you want to access one of these items, you just use those indices up here. 0, 1, 2, 3, 4. It's a 0-based index. So colors of 0 is going to be red. So when I step into this here, it prints red. You can take the length of the dictionary by the keyword len. So when I take the length of this, it's not going to be 4. It's actually going to be 5 because we're 0-based here. So we'll go through that. 5 colors available. If you want to find if something is here, you can just use the value. Okay, the value available. In this case, they're going to be strings. In other cases, they could be numbers. It could be just about anything. If red is in colors, print found red. If you want to loop through a list, which is very important, you can use what we call the for each loop. And what you do is you say for, and then you give a new variable for the element that is in the list. So whatever these are, it's a set of things, in this case strings. It's going to take one of those strings at a time and put it into this variable color. So when we step through here, notice we get a new color, red. So it took the first one, red, and it's going to print that. Now it's going to take the second one, orange, yellow, blue, violet. So it's going through this list, and it's always giving you whatever the value is. Now you can also go by indices. You can do for I in range, len, colors. And sometimes you have to do that. We'll get down to there. Sometimes you have to do that because you actually need the index of where the color is. Other times you don't. But you can also add colors to here. So look, we're going to actually add another color, green. So let me step down there. So watch the end of this. 0, 1, 2, 3, 4. Watch for a 5th item to come in. There we go, green. And we can remove items. Now there's 2 reds now. No, there's still only 1 red. Okay, so we're going to remove this red over here. There we go. And now I'm going to use those indices to print the colors out. So orange, yellow, blue, violet, green. Okay, now let's go down to dictionaries. So dictionaries you create with these squiggly brackets instead of the square brackets. And you give a key and a value. Typically, you are not manually creating a dictionary like this because you're typically, well, you can, but typically you're creating this dictionary for like a large number of pieces of data, and so you're actually going to be storing them. Maybe you're reading them from a file or something like that. But you can create these manually. So we're going to first print the length. So notice the same keyword len works for lists and dictionaries, grocery lists. There are len items in this, 8 items. And now I'm going to print the grocery list. And that's that same format that we use to enter it in. Now, an interesting thing about dictionaries is you can separately take the keys and separately take the values. So you're going to remove you're not going to remove, but you're going to just take this left column or this right column, and you're going to lose the association. But we can go ahead and do that. We can print out the keys. Here's all of those strings. And then the next step is I'm going to print all the values. And now it's just going to be a bunch of numbers here. Now here's a big difference. Whereas in lists, you can use the index and say, give me colors too. You cannot do that in dictionaries. I won't get into too much detail as to why, but these items can actually change around and whatnot. So having an index really doesn't mean much. So instead what you do is you have to actually give it one of these keys here. like noodles, or in this case, honey. It's going to look in here for where honey is, and then it's going to actually give me the number in return, 2. There it is, 2. Now, if you want to add items, we used append and remove there. So for the version of append, what you do is you actually can index into it by the string and give the value. I think it's a little bit odd. And then instead of remove, you pop the name. Does it look like 2 different people created these data types? I think probably that was because they didn't use the same names. So we can add eggs to the list, and we're going to remove lemons. Look at where lemons is. That's the very first one. Watch what happens when I do this. Okay, lemons disappeared. And then you can do the for each loop for item and grocery. We're going to print these out. So let's just go through that. So it looks at all these values here. And then you can also do the same thing. If an item is in the dictionary instead of the list, you can just check it like that. So lists and dictionaries, very important data structures that you're going to use in just about anything of any real significance. So that was the introduction I wanted to give to lists and dictionaries. Now let's take a look at the actual problem they want you to do this week. Heads up. So we're going to skip over to heads up here, and there's a separate file that they give you this week called cswords.txt. I created a simple one that I've named cswords2.txt just so it's short and we can really see what's going on. So this function is already given to you, and I wouldn't pay too much attention to what it does, but basically, as the name implies, it gets the words from a file. So it's going to get the words from a file, and then how is it going to return it to us? It's going to return it to us in a list of those strings. So let's start out really simply. There are 3 milestones they give you, and it's really good that they give you the milestones, because whenever you write a program, you want to break it down and think, okay, what's the smallest program that I can write towards this goal, and then run it? And then what's the next smallest step I can write towards this goal, and then run it? Always do that, because you don't ever want to write 100 lines of code and then find, oh, gee, it doesn't work. And now where am I going to begin diagnosing it, right? Write as few lines as possible and then run it. All right, so milestone number 1 is just to read the provided function into a list. Okay, so let's just try reading that and then printing it. Get words from file doesn't take an argument, which is really bad because it really should take the name of the file, but it doesn't. So instead, I've modified this hard-coded string here, cswords2.txt, and I do want you to take that to heart. Okay, why? This is not a good design, right? They've got a function that reads words from a file, but why they should have taken the file name so that you could call it from other places. It's bad design. But get words from file, and let's assign it to something. So let's call this lines equals get words from file, and then let's print lines. That's about as small as I can do. Let's try running that. All right, so we have 5 words here. That's good. That's exactly what we wanted. Let's further, and let's say print there are, and then do length of lines. There are 5 words in the list, colon, and then lines. Let's try running that. There are 5 words in the list. Good. So what's milestone number 2? Show a randomly chosen word from the list. All right. Now we have to think. We're going to show a randomly chosen word from the list. The word randomly. Okay, so we know that we've got to do something with random. Let's check and see. Did they give us an import to random? Oh, they did. Okay, so that's a good sign that we're on the right track. So we need to use random, and we know how to generate random numbers. If you recall, remember how do you generate a random number? You have to do random, because that has to match the name of that import up there, dot, and then rand int, and then you can give it a range from the beginning to the end number, including those ends. So we want to start at what number and end at what number? Think about that for a second. What's the lowest number of this list? Is that 1? No, it's actually not. It's actually index 0. If you think back to the Python tutor, right? Index 0 is the first item. So if you were to do 1 here, it might seem it was working, but you're never going to get to item 0. So we put in 1. Now, what's the top number? Again, let's look at Python tutor. So there are 1, 2, 3, 4, 5 items here, but the top index is 4. So you could put in length of lines, but what's the length of lines? Well, it's 5. Did we have index 5? We didn't. So this would actually be 1 too many. So you would actually crash because you're going to try to index into an item that doesn't exist. So you need to remove 1 from there. So that's a random integer. Now let's store that into this and say choice equals that. And now let's try printing. Random index choice. Okay, tabs are wrong. So that was a really weird error. I don't know why. It didn't look like the tabs were wrong, but after I deleted and added everything else, now it works. Okay, so there are 5 words in the list. Random index is 2. Let's try a couple of different choices. 2, 3, 4, 1. Do we ever get to 0? We should get to 0. There are 5 words in the list. Now, interesting, we should be only getting to random 4. 4. Oh yeah, we just went over this issue. I think I must have been trying to show you the error. So we should be going to 0 to 4. So we got 0, 1, 4, 3, so 2. Good. So you notice that I used that small file because imagine I tried to start with what they gave us with like 42 words. Am I going to be sitting there refreshed to see whether I actually hit 0 and 42? Well, 41. No, it's going to be too much. Start with small data files whenever you work with data files. All right, so now we've gotten a random choice. Now we've got to remember, what is it we're trying to do? We're trying to, oh, actually, let's put this down here to milestone 2. We're trying to show the randomly chosen words. We've got a random choice now, so now we need to actually show the word. So we got to remember, how do we index or get an item out of a list? So what was the command, the code, to get an item out of the list? Remember they have these indices here, like number 2? So in order to do that, what you just do is you use these square brackets to index into a list. So let's go back there. So we want to now print random word is, so we're going to use lines, and then we have to index into it. And the index value, not P, the index value is choice. Let's try running that. Random word is Harry, Ron, Hermione, Ginny. So looks like we're getting all the correct values. Now the last challenge, milestone, is wait for the user to hit enter and then show another word. Okay, so let's take this one bit at a time. How do we wait for the user to hit enter? Remember, thinking back to the console programs, what did we do when we wanted to input a value? Oh, input, right? Wasn't it called input? So we know that we're going to have to put an input statement here. Input press enter for a new word. So now if I run this, it gave me the value, and now it's going to wait until I hit enter. Okay, so that's the first part. It's going to wait for the user to hit enter, then show another word. So we just went about this process of showing a word, right? How can we make it go back up to here? This is the while ever loop, right? Remember how we do that? While true. Because these indentations matter, we're going to have to indent all of that. So while true, it's going to keep on doing this. So it's going to come back up here, choose another word. So let's just try running that. Hermione, Harry, Hermione, Ginny, Hagrid. So that seems to be working. Now we used a small data file here, so let's go back up and change this to the big data file. Run. So now we've got all these words down here. So let's try hitting this a few times. Function, for loop, starter code, main, Maron, float, Stanford. Okay, so it looks like this is working. What was that one up there? Burrito? Why is there burrito in this list? I honestly have no idea what burrito is, if that is a computer science word. Maybe that's just their joke. All right, so we have now accomplished the heads up task. It's not a great demonstration of what we learned this week because it didn't use dictionaries at all. You can imagine that we can go and edit a different file. Instead of this cswords2.txt, we could edit it to have 2 words in here. And then we could read it into a dictionary instead of a list. And then we could manipulate that. That's a good exercise for you to try. But let's go back now to the next thing, baby snake. So let's take a look at the baby snake assignment. And then we will go and actually take a look at some code that'll be helpful. Okay, so let's open baby snake. All right, so baby snake, the goal is, let's just, maybe I should just show you how mine runs. Let's run this. So you're this blue player here, and then you're trying to hit this goal. And so you need to use the keyboard. So when I press right, and then I press down, it hits it. But then it resets, and I've got to track it again. And each time I actually manage to hit it, my score is going up. I'm sorry that the screen keeps on scrolling. It's just an unfortunate size for this resolution. Okay, so gee, I could stay here all day. What a fun game. One tip is don't make your delay too short or this game becomes very hard to play. All right, so as soon as it runs off of the screen, then the game is over. Your score is 7. So let's go back to see what is going on here. So the player is always going to start in the upper left. The goal is going to be at some random place, and this is a grid of 20 pixels. They say configuration of 360 or 360, but you know the grid that they gave you is 400. And you are going to be using some code to handle the key presses. I guess they don't want you to do that. First, they just want you to animate the guy moving to the right. Okay, that's very similar to what we did last week. And then they're going to have you handle the key presses. And they give you all the code here to get the key press and then determine which key press it is. And then you're going to have to detect collisions. And they give you code here to determine what the X and Y is of an object. And then they want you to move that goal to other places. So here they give you, again, random int. And that can be used to figure out where to place it. So I'm not going to go over I'm not going to show you the code to this because they want you to figure it out on your own. You should. But I will take a few minutes and talk about what things to think about in each of these aspects. Now, to assist in that, I want to show you this code here, the erase canvas worked example. So this example here is done by the TA and it does something similar. I'll go ahead and run this. So what it does, it fills in the screen. Let me move this over here so we can see it. It fills in the screen with with the same dimensions, 400 by 400, same block size, 20 by 20. And you can see how he's drawn individual blocks there. In this case, as soon as I click, it starts to analyze where is this eraser. And anywhere that this eraser touches, it starts erasing that block like this. So this is not exactly the same, right? It's using the mouse instead of the keyboard, right? That's one thing. And there's no animation involved here. Well, there is the animation of moving the eraser, right? But there's none of the blocks are moving around. But it's a good place to start. So what I suggest you do is you take a look at this erase canvas, and I believe so he narrates through the video how, I think it was Brahm, how to do this. He didn't actually give you the code here. You're going to have to type it in yourself, which is great. You really should do that. But it gives you some sense of how do you calculate where a block is given an X and a Y. That's a very important thing that you need to figure out. Where is this block? Okay, that's what this one will help you figure out. So I would suggest you look through this code to get a little experience with that. Well, let's go back to Baby Snake again. So number one, set up the world. It's basically the exact same code as what they did in the erase canvas erase, except it's actually simpler because you don't have to put any grids. You don't have to do that. The only two things that you have to add here are creating the player and the goal. And I want you to think about creating the player and the goal are both very similar. Given an X and a Y in terms of blocks of 20, so there's going to be 20 blocks across and 20 blocks down based on a 400 by 420 size. So there's going to be 20 blocks across, 20 blocks down. Given an X and a Y, where is that block? What are the extents of it? Top left, bottom right. So that's common code. You should really try to make a helper function that creates your X and Y based on based on which row and column you want to put it in, because you're going to be using it over and over again. Because not only do you have to draw the player at 0, 0 to begin with, but then you're going to need to animate it, right? So every step along the way, you need to know where is that block. So that's the first thing you should work on, is actually figuring out how do I calculate the pixel X and Y here given a row and column from 0 to 20, or it's actually 0 to 19. Then you will be able to place the player and place the goal. Goal is going to be a random number. So we talked a little bit about how you can use the random number. I think I showed it to you earlier today. And so pick a random X and a random Y, and then place the goal there. And remember that later you're going to need to do that from multiple places in the code. So again, you think about, can I have a helper function that does this, or what do I need to do? So that's how you're going to set up the world. Okay, number two is animation. So once you have a routine which puts the player at a particular spot, all you need to know is, and you have code that calculates given how a spot is changing, right? You can then not easily, but you can understand how you can animate something, right? You now have a way to calculate the X, Y at each position, and you have a way to draw that block at each position. And remember, we're not always going to be creating that rectangle. We're actually going to be moving that rectangle. And you should look at the difference between move and move to, because move allows you to give it a change in X and a change in Y, versus move to lets you give it that X and the Y, but you also have to give it the top left and the bottom right. So think about which of those you want to use. And so step 2 is just to make a move right across the screen. Now step 3 is to handle the key presses. So they give you this loop here. So you should just put that loop into your code and make sure that that's working. Now for each of these cases here, what are you going to do when you press arrow left? What are you going to do when you press arrow down? You should be thinking about, there is this certain amount of step. You could do this multiple ways. I mean, you could just look at key, and then depending on what key was, no matter what, at some point you're going to have to start doing math, okay? So I would encourage you to think about, you have a delta in the X and a delta in the Y, depending on which key was pressed. So if it's left, you're going to go negative size as your X, or -1 if you're talking about blocks. If you're going down, now your dx should be 0, but your dy should be negative size or negative, well, actually that's +1 going that way. So think about how you want to represent the effects of each of these buttons. Okay, that's once you do that, now you already know how to draw your player. So far you were just animating him right. Now it might be any direction. Okay? Detecting collisions. So this code lets you get the X and Y of an object. Well, what objects? Well, there's two objects. One is the player and one is the goal. So if you get the X and Y of the player and the goal, if they are the same, then you know you've got a collision. So that should give you what you need to know to do. And if these things align, then what are you going to do? You're going to move the player or the goal somewhere else and increase the score. The score is optional, but that's part of what you want to do. And yeah, so moving the goal, again, I already mentioned, to move the goal, you just need to calculate a new random position. Hopefully you may have created a helper function that already does that for you, so you can just call it again. So again, I'm not going to give you the code for Baby Snake, but those are the things you should be thinking about as you're going through here. Well, I think that's about it for this week and for the whole class. So thank you very much for sticking with me, and I hope that you do continue your education. Again, I would recommend that you look at the W3 Schools Reader and also how to automate the boring stuff with Python. It's a great next step for you, which will give you a lot of interesting examples on the web. All right, goodbye and good luck to you.